Let's continue the topic continuity and let's do one more sum on continuity of a function on an interval. The question is, determine the constant k if it exists so that the function f defined by fx equals to k times 3x square minus 5x for x less than 0 and 1 plus sin x for all x greater than equals to 0 may be continuous. Now, when you look at this question, they have not told you the function is continuous at a given point. So you have to find out the domain of these expressions which are defining the function. So we find the domain of these functions is set of all real numbers. Now, if this function is continuous, it means it's continuous for its entire domain, which is set of real numbers. Then it should be continuous for every point in its domain, and 0 for which the function is defined towards the left, towards the right, as well as at 0. This means the function has to be continuous at 0 also. So we write x equals to 0. The function is continuous at x equals to 0. So let's try to find out limit extending to 0 plus f of x. So limit extending to 0 f of x will be given by limit extending to 0 plus, which function is defined towards the right side of 0. For x greater than equal to 0, it's defined by 1 plus sin x. So we have 1 plus sin of x. And when we put the x as 0 here, 1 plus sin 0. Sin 0 is 0. So the limit of this function turns out to be 1. Now next we find the limit extending to 0 negative. That is left hand limit of this function when x tends to 0. When we find it becomes limit extending to 0 negative. The function defined towards the left of 0 is by k times 3x square plus 5x. So it's k times 3x square minus 5x, which turns out to be k into the value putting x as 0, and here also 0, it becomes 0. So k into 0 is what? 0. Whereas the value of function at 0 is defined by this function 1 plus sin x, which becomes 1 plus sin 0, that is 1. Now what do you find here? The left hand limit and the right hand limit are not equal. That is called non-removable discontinuity. That means no value of k can make this function continuous. So no value of k exists. That's why they have mentioned if it exists. So here the right answer is no value of k. No value of k makes this function continuous. No value of k can make this function continuous. As left hand limit extending to 0 f of x is not equals to limit extending to x 0 plus f of x. Okay, so this is about the sums that I have done it. Now moving on to the one more property, that the properties of the continuous function, that also you have to know. Here, if f and g are two continuous functions at a given point x equals to c, then the multiplying the function f with any real number alpha, the function will still remain continuous at that point x equals to c, where alpha is, again I told you, any real number. The sum of these two functions which are continuous at x equals to c, difference of these two functions, or the product of this function, the continuous function, will also remain continuous at the same point x equals to c. Even the division f upon g is continuous at point x equals to c, except those points where if the f of c becomes 0, except those points where g of c becomes, the value of function at c becomes 0 for the denominator. Similarly, if it is g upon f, then we'll say the function is continuous for all points x equals to c, except where f of c becomes 0. Here in this case, g of c equals to 0. In g upon f, f of c equals to 0. Now, the second set of properties we have, if d1 and d2 are the domains of the continuity of the function f and g respectively, in this case, both functions were continuous at point C. But here they have both functions have different domain of continuity. In that case, f of alpha will remain continuous in its domain d1, where alpha belongs to real number because domain of f was d1. Here, sum of these two functions and difference of the two functions or the product of function will remain continuous in the intersection of their domain of continuity, the common points of their continuity. Whereas f upon g will remain continuous in their intersection except where f of x becomes g of x becomes 0. This is what you have to know, the properties of continuous functions. So when you have mixed functions and you find both functions, if you independently can prove them continuous, then you can use these properties to say that some of those two functions will be continuous. And this in fact will be used in the mean value theorems that we'll study the chapter in the upcoming exercises of differentiation.